In this video, I'm trying to clear a doubt that was expressed in the class, but I couldn't answer at that time. So the doubt was regarding the energy stored in a capacitor. So the student asked that, say I have a capacitor with capacitance C, and say this is charged with a battery with voltage V, then my derivation that I did previously says this energy stored in the capacitor, energy in the capacitor EC is equal to half CV square. But the student asked that let the charge stored in this capacitor be Q, and the voltage of the battery is V. So the amount of work done or the energy supplied by this battery, so the energy of the battery is equal to Q times V. Now V is equal to C times now Q is equal to C times V, so this is equal to CV square. So why do these two not match? So here the amount of energy supplied by the battery is CV square, but here according to my previous derivation the energy stored in the capacitor is half CV square. Why do they not match? So here is the answer. Here we are ignoring by mistake the resistance of the cables, connections, etc. What happens is that initially the voltage across the capacitor is 0. So V, this is time, this is VC. VC is initially 0, and it increases slowly as it gets more and more charge. So at that point, when the voltage across the capacitor is 0, the entire voltage of the battery is dropped across the this resistance R. So if the current at that point, so let me draw the current. So as you can expect, initially there will be a high current, and this current will decrease slowly because the capacitor is getting charged and it's opposing the voltage of the battery. So the current decreases slowly. So initially whatever is the current is, it's flowing through this resistance, and this I times R is wasted. And initially, since the capacitor voltage is 0, so capacitor is not opposing any this charge transfer. So initially we are not storing any energy in the capacitor. But then when this voltage increases to some value VC, then at that point the current decreases. So I now have a decreased amount of current. So I times R is reduced because I is reduced. But at this point the capacitor is increasing, and opposing force opposing the charge transfer. So that will cause me to do some work which is stored in the form of electrostatic energy in the capacitor. So then part of the energy is stored here, but still some part is getting lost in as I square R lost here. Therefore always there is an amount of energy which is lost here and an amount of energy which is stored in the capacitor, and the energy supplied by this battery V is sum of these two energies, and therefore we have this discrepancy. And it also suggests that the amount of energy wasted is equal to, so ER, energy that is wasted is, that is converted to heat, is equal to the difference between these two. So CV square minus half CV square is equal to half CV square.